Good morning, America. Today, we're looking at new legislation being passed to... What? Oh my god. Breaking news. Here in LA, today's temperature is observed to be 127 degrees Fahrenheit. Let's put this into perspective. Where does 127 fall under the normal distribution for temperatures in LA for today? Is this abnormal? Wait, Caitlin, what are normal distributions?
That's an excellent question, Ryan. So let's talk about the characteristics of normal distributions. First, they're defined by mu, which is the center or the mean of the distribution, as well as sigma, which denotes the standard deviation. Obviously, when you're dealing with variables such as temperature, this varies from day to day. Additionally, normal distributions are unimodal, meaning there's one peak, symmetric about the mean, in which the mean is equal to the median and the mode, and it's also bell-shaped. It's also important to note that the total area under the curve is equal to 1 or 100%, and the curve never touches the x-axis. One specific type is called the standard normal distribution, in which the mean is equal to 0 and the sigma, or the standard deviation, is equal to 1. Now, looking over some basic calculator functions, norm CDF or normal CDF finds the area under the curve, or the probability of getting a value between A and B, which are specified given that the mean is a certain number and the standard deviation is also a certain value. Inverse norm finds the z-score using the area or percentage from the normal distribution. Now, over to Ainesh to tell us about the empirical rule.
Thank you, Caitlin. And now moving on to the empirical rule, which is measuring the area or percentage of the normal distribution that contains amount of standard deviations away from the mean. So the first section or area of the normal distribution is 68%, and it is a section which is one standard deviation away from the mean. And the next one is 95%, which is two standard deviations away from the mean on the positive and negative side. And last but not least is 99.7%, which you guessed it, is three standard deviations away from the mean on the positive and negative side. And to measure each section just by itself, the first section, one standard deviation away from the mean, is 34%. Then the next one, which is two standard deviations away, which is 13.5%. Then it is 2.35%. And the last one, which is outside the three standard deviation boundary, is 0.15%. And it is the same on both sides since normal distributions are symmetrical. And now onto the next topic, which is subtracting and adding normal graphs. And it's very simple. If you want to subtract or add a normal graph, for figuring out the mean, you subtract the mean or add the mean of whatever graphs you're adding and subtracting. And for standard deviations, even if you're adding or subtracting, doesn't matter which one, you just take the squares of both of the standard deviations of both graphs, add them together, and take the square root of the entire thing. And finally, for z-scores, our last topic. And it is found by taking x, or a sample data, or sample statistic, minus mu, or the mean, and it is all divided by sigma, or the standard deviation. And it is used to find the distance from the mean in terms of standard deviations for a point estimate. And a point estimate is a sample statistic recorded from our sample data, which is basically a single point. And for our temperature context, our point estimate is 127 degrees Fahrenheit. And with our mean of 66 degrees Fahrenheit and our standard deviation of 6.03 degrees Fahrenheit, we can now calculate the z-score with our good buddy Eric for 127 degrees Fahrenheit.
Thank you, Ainesh. Now, let's get into some calculations. First, let's find the z-score of 127 degrees Fahrenheit. The mean temperature for any given day in Los Angeles around this time is 66 degrees Fahrenheit, and the standard deviation is around 6.03 degrees Fahrenheit. Now, using the formula z-score equals x minus average and then divided by standard deviation, the z-score can be calculated as approximately 10.1161. But this number doesn't really show the probability of getting such a temperature. So now, let's use normal CDF to find the probability of having the z-score. Setting our lower bound to 10.1161 and our upper bound to infinity to find the probability of a z-score of 10.1161 or higher, the probability of experiencing temperatures of 127 degrees or higher is 2.39 times 10 to the power of negative 24.
2.39 times 10 to the negative 24 probability? Holy cow. That means today's temperature isn't normal at all. Stay safe, everyone.
Oh my god, let's see how that turned out. I think I need to re-record the second part, but it's okay.